So I realized after grading the quizzes that there's a lot of confusion about dilations, which is totally my fault because I didn't explain it to you guys or anything like that. So I thought what I would do is actually go through a couple dilation examples with you guys. So these are actually straight from the 11.1 classwork packet. And then what I'm going to do is I'm going to put a new quiz up for tomorrow, so that way anybody that didn't get a very good score on the quiz, if they want to try to get a better score, I'll take the better of the two scores on the quizzes. So let's jump in and talk about these dilations. So the main thing we're trying to do is when we've got a dilation, the scale factor is going to tell us whether it's going to be an enlargement or a reduction. So if it's a number bigger than 1, it's going to be an enlargement of the figure. If it's smaller than 1, then it's going to be a reduction of the figure. So in this case, we've got a little square and we want to make this into a scale factor of 2. So essentially we want to double the size of the square. So the first thing we have to do is we want to see where our dilation point is. So in this case, that's our point 0. And then what you want to do is connect. Typically you would connect all the vertices, but sometimes you can get away with not connecting all the different vertices and still get the right answer. So, because it does get a little muddled sometimes with all the different vertices. So the square, typically you don't necessarily have to do all of them. So we'll see. So the first thing I want to do is start with at point O and then draw a line through those two. So technically I hit 2 vertices on that side. And then I'm going to hit the next corner. And so in this case, notice that our square originally had sides of 1, 1, and 1. So that means our new square has to have sides of 2, 2, 2, 2 the whole way around. So when we're trying to figure out where our new square is going to be, what we're trying to do is we're trying to find where all these lines kind of intersect and give us lengths of side 2. So in this case, if I notice, here to here is a nice length of side 2. So that means this side of the square is actually going to be the same as that side of the square. And again, if I'd have drawn this extra line, I'd have seen that that dot would be this vertex on the square. And so now I can kind of fill the rest of them in. And so that's my square that's twice as big as my original square. So again, that's what you want to do. You want to kind of connect up all those vertices and then go from there. So let me do this one down here, this triangle with a scale factor of 3. So again, start off the same way. So what we want to do is kind of draw lines that go through our vertices. And so again, in this case, our triangle had sides of length 1. So that means our new triangle has to have sides of length 3 in this case. So if I kind of look around, I'm trying to figure out where this side will be. The other side will be easier because it's got the 2 vertices. So really the hard part is trying to figure out where that side is. So what I want to do is kind of look and see where would be the first place I have length of 2 or length of 3. So in this case, this part here would be a side length of 2, so that's too small. But in this one, I've got 1, 2, 3, so that gives me a side length of 3. And then if I do the same thing on the vertex side, 1, 2, 3, that's going to give me to that point there. And so again, just connect these two up, and that's going to give me my scale factor of 3 triangle. So again, that triangle is 3 times as big as the original. All right, so let me do a shrinking one, just so you can kind of see what's going on there too. And then again, like I said, if you have questions about this video or about these after I post it, definitely ask. Don't, let me know that you don't understand something. So let's do the scale factor of 1/4 and see how we do. So again, our point zero or point zero point is up here. So again, what I want to do is draw lines that connect these different vertices. So I need one line going there. One line going there. And in this case, I am going to go ahead and try to put that third one in just to see. Might not need it, but all right. So again, we always want to look at our original size just to see how big it was originally. And so if we notice, like the side length of that rectangle, or that side of the parallelogram is a side length of 4. So since it's a side length of 4, and we want to get a scale factor of 1/4, then that means our new parallelogram has to have a side of length 1. So when you're looking, so again, what I'm going to try to do is try to figure out where this guy is going to end up on my picture. So what I want to do is I want to go through and kind of compare these two lines and see if I can find the place where it's only 1 dot wide. So as I glance through, there's definitely 4 dots here. It's a little bit more than 3 here. Looks like it's about 3 there. It's going smaller and smaller and smaller. So finally, when we get to there, we finally get our size of 1 in this case. So now what I want to do is I want to figure out where this side would be. So again, it's going to use this line and this line, and we want that to be a side length of 1. So if you notice, those two lines exactly give us a width of 1. So now connecting the dots, I'm going to get that one and that one. So there's my parallelogram that's 1/4 of the size of the original parallelogram. So hopefully this makes things a little bit better. If there's other ones, glide reflections, translations, if there's other ones you guys are still confused on, let me know. Dilations definitely seem to be the worst on the quiz. So hopefully this will help. Redo the quiz if you want to try to get a better grade. Ask me questions if you have any. Otherwise, I'll see you guys tomorrow.